So in this video, we're going to look at graphs of functions and then approximating derivatives. So the first one here, we're looking for the approximate derivative at -4. So you can see the derivative is the exact same concept as slope. So slope, if you recall from college algebra, is delta y over delta x. And for calculus, the derivative of a function is really the limit as delta x goes to 0. In this case, the slope at x equals -4 is going to be the derivative is going to be the approximate slope. So if I think of the slope as rise over run, I go up 2 units and I run 3 units. So the slope here would be 2 over 3. The slope at -1, well, this would not exist because if you recall, it's going to be the limit on the right has to equal the limit on the left. So if we look at the -1 point, the slope on the left is going to be 2/3, but the slope on the right is going to be 0. So that's why the slope doesn't exist there. At x equals 2, what's the slope at this point? It's going to be rise over run, which is 0, over a number, which is 0 there. So anytime they give you a graph, and this might happen on the final, and they might ask you to approximate the slope at some point x equals 4. So if they give you points, they give you any other point on the graph, right? Then the slope of the secant line is going to be approximately the slope of the tangent line. And the closer you can get to your actual point, the better approximation you're going to get. So if you think of delta y over delta x, this is the slope of the secant line. The closer you can get to the actual point gives you a better approximation of the slope at that point. So here, this is a constant slope, and here, this is a constant slope. The reason why it doesn't exist at -1 is because there is the limit on the right and the limit on the left doesn't equal each other. The slope this way is different than the slope this way. So hopefully this kind of explains anytime, let's just think if we have x squared. Your book does this. And if we look at x equals 1, at this point would be 1, 1. If x is 2, you have 2, 4, right? We know the derivative is y equals 2x. So at x equals 1, the slope is 2. But we could approximate it by taking 4 minus 1 over 2 minus 1, which would be 3 over 1. So the closer we get to our second point value, right? So maybe this would be 3 over 2. The closer we get to this, the better approximation we're going to get of the slope. So if I took the limit there, we would get a better approximation of the derivative at that point. So you can always think that the derivative of a function at x is going to be approximately the change in y over the change in x at that point. And again, this is just an approximation. It's a quick and dirty way to approximate the slope at a point, is take that approximate secant line. So hopefully this helps. If you have any more questions, let me know.